Okay, so the first part here, let's just have a look at some of the little properties of defining our evaluating a definite integral. Okay, so if we want to evaluate a definite integral, which really means that we've got certain limits of integration. So really to evaluate a definite integral, we work out the antiderivative of the function, which we're saying is capital F of x, and all we do is substitute in the top terminal point and we subtract the bottom terminal point. So f of b minus f of a, where capital F is simply the antiderivative. And we've got a few properties here. Obviously, if the points are the same value, we just get f of a minus f of a, so we get 0. We can split up our interval, okay? So for example, what that says there is that this interval from say 1 to 3 is equal to the integral from 1 to 2 plus 2 to 1. If we have a constant inside the function or the integral, we can bring it out the front. And if we have multiple functions, well, we just add and subtract them as we go through. Another really nice one, okay, if I'm working out the integral from, let's put a thing out, if I'm working out the integral from 1 to 2 of f of x dx, well, that's the same as working the negative of 2 to 1 to swap those endpoints around, okay? All right, so let's just do a couple of routine problems, and then in the next exercise we'll talk about how it applies specifically to evaluating areas. So step 1 is we need to work out an antiderivative. So 3x to the 3 on 3, so I'll put the whole thing in, plus 3x to the 2 on 2 plus 2x evaluated between 2 and 0. Okay, so obviously once we work out our antiderivative, the dx symbol goes, the integral sign goes. Perhaps before I work it out, 3 on 3 is the same as 1, so x cubed plus 3x squared on 2 plus 2x. Substitute my first point in, so I get 2 cubed plus, let's just undo that, plus 3 times 2 squared over 2 plus 2 times 2. Notice everything I substitute in, I put in a bracket, and then I'm going to get 0 cubed plus 3 times 0 plus 0. All right, so simply we get 2 cubed, which is 8, plus 2 squared is 4, 12 over 2 is 6, plus 2 times 2 is 4, minus 0, and we get 14 as an answer. All right, let's do a few more. Okay, so let's remember with integration, we don't have a quotient rule or anything like that. So if we have a quotient, for us, typically it means we have to split it up. So x squared on x squared plus 1 on x squared dx between 1 and 4. So that's the same as the integral between 1 and 4 of 1 plus x to the minus 2 dx, which if I work out the antiderivative now, that becomes x plus, add 1 to the power, so x to the minus 1 over negative 1 between 4 and 1. So let's come up here. So we'll just tidy that up a bit more and go x minus 1 over x between 4 and 1. Round bracket now, 4 minus 1 quarter, subtract 1 minus 1 on 1, which is 3 3/4 minus 0, which is equal to 15 on 4. All right. C, we've got our rule for anti-differentiation. Remember, it's our ax plus b to the n rule. So the antiderivative here is given by 2x minus 3, add 1 to the power, so I get negative 1 over negative 1 times the coefficient of x, which is 2, evaluated between 2 and 0, which means if I just tidy that a fraction, negative 2 on the bottom, I get 1 over negative 2 times 2x minus 3, evaluated between 2 and 0. So if I put 2 in there, I get 1 over negative 2 times 2 minus 3. minus, put 0 in there, 1 over negative 2 times 0 minus 3. So what have we got? We've got 2 times 2 is 4 minus 3, which is 1. 1 over negative 2. Subtract. 2 times 0 is 0, minus 3 is negative 3. Negative 2 times negative 3 is 6. It's 1 over 6, which is, make them both 6s. I get negative 3 minus, that's a plus, isn't it? Plus 1 on 6. Negative 2 is 6, which is minus a third. Okay, now let's give ourselves a little bit more room in here. Same thing. Now, what we should notice here straight away is that the graph, the antiderivative of x to the minus 1, have we covered that? Yes, we have, so it's all right. Here's the natural log of x, good. So that's going to be natural log of x minus, now we've got k out the front, so 1 over a half e to the half x between 2 and 1, which is equal to the natural log of x. 1 over a half is 2, minus 2e to the half x between 2 and 1. Let's put 2 in. I get natural log of 2 minus 2e a half times 2 minus natural log of 1 minus 2e to the minus a half. Why am I putting minus? Positive a half. So natural log of 2 is natural log of 2. We get minus 2e to the 1. Natural log of 1 is 0. E to the half, minus times a minus is a plus, so we get plus 2e to the half. So there's my answer there. All right. Final one is, okay, antiderivatives is we get 1 on negative 2e to the minus 2x minus 1 on k, which is 1 on 2e to the positive 2x between 1 and negative 1. Substitute 1 in, I get minus a half e to the minus 2 minus a half e to the 2. Subtract minus a half e, negative 2 times negative 1 is positive 2, minus a half e, 2 by negative 1 is negative 2. So from in here, I'm thinking I get minus a half e to the 2 minus a half e to the 2, to the minus 2 that should be. Minus a minus is a plus, a half e to the 2, minus a minus is plus, a half e to the minus 2, and now I've got minus a half e to the minus 2 plus a half e to the minus 2 cancel out, minus a half e to the 2 plus a half e to the 2 cancel out, so I get 0 as an answer. All right, so really important we just practice evaluating our integrals at this stage.